Steve, are you there? All right, just a few more minutes. I apologize, everyone. I'm actually going to try and contact him and make sure he didn't get disconnected. Just one moment. Keith, are you there? Hello? Again, everyone, we apologize. Just a few more minutes. I do have him on the other line, and we're trying to get him set and ready. Just one second. We apologize.
Restoration, crack repair. Okay, am I there?
Keith, are you there?
I am.
Okay, we can hear you now. Great. If you wouldn't mind going ahead and pulling your presentation back up when you can. And then just the same as before, you'll want to hit the button where it says Show My Screen.
Yeah, I am.
Okay. All right.
Apologies.
And just one moment, I am going to disconnect with our tech department. I'm going to put you on a brief hold, and I'll be right back. Just one moment.
Okay, now how do I get to show my screen? I don't have any of the buttons. All the buttons are gone. I'm a panelist right now. Yes, side control panel is what it says.
Yes. Okay, hold on one second. I might need to change your position here. Okay. I'm going to make you the presenter and the organizer.
Okay, now show my screen back.
Okay.
Well, I'm just on myself when I sit down.
Okay. Now, Steve, I am not, do you have this phone up now?
Yes, I do.
Okay. All right, I can hear you. Your screen is in full view. So if you want to go ahead and you can scroll back to your first slide. And I have already introduced you. Sorry about that. I didn't realize you were having trouble on your end. So whenever you're ready, everyone, thank you so much for your patience, and we apologize for the technical difficulties. And now I will re-present to you Mr. Steve Young.
Thank you very much, and thank you all for coming, and thank you for your patience. Today we'll be talking about corrosion of pipe supports, causes, and preventions. And here's the problem. Corrosion of pipe supports is the leading cause of external corrosion failures on above-ground piping systems, and today we're going to talk about why. The reason why is there's poor designs and misconceptions about pipe supports and the causes for corrosion. Some poor designs are that the pipe supports form crevices. They also trap water at those crevices, they hold the water, and they're very hard to inspect. Some misconceptions are that rubber helps and that it's critical to eliminate metal-to-metal contact, and basically it's a galvanic thing. What really goes wrong is that water gets in, water stays in, the paint or coating fails, then the pipe hits through and the pipe leaks. So let's take a look at how that actually works in these pictures here. Here you have a pipe sitting on top of the pipe support structure. Both the pipe and the support structure are coated with an atmospheric structural coating and a pipe coating. And where those two meet, the pipe and the support meet, there's a crevice formed, as you can see. Now water gets trapped in that crevice. And this atmospheric coating, which is designed to be dry, now at that location of the crevice is basically an immersion service. It's submerged in water all the time, and it's designed to be dry. So the atmospheric coating softens and fails. Now you have bare steel exposed to oxygenated water at that location. And this causes a galvanic cell, localized wall loss, and progressive undercutting of the paint. And the result is leaks. Lots and lots of leaks. And this is a typical corrosion pattern that we see at pipes on pipe supports, and it's a huge problem. It's a major threat both offshore and onshore, anywhere where you have pipes supported by metal, and especially in areas where there's lots of moisture in the air. But we have rubber pads. They eliminate the metal-to-metal contact and stop the galvanic action, don't they? Afraid not. As you can see here in this slide, there's still corrosion happening, and the coating is failing at the support, even though the pipe and the support are separated. Think about it. The rubber forms a capillary scaling crevice that sucks and holds water, which stops evaporation, sets up an oxygenated concentration of cells, and rapid crevice corrosion. However, those rubber pads just keep appearing. So we say, no rubber. Some other bad designs that break the basic rules of corrosion. I need to move this over. One, the basic rules are don't trap water, don't hold water, like we said, no rubber, and make it inspectable. Another bad design is this FRP wear pad, as you can see here in the picture. And this is a FRP material that is applied with caulk and then epoxy and then caulked around the edge to stop. The idea is to stop water from getting in there as well as allow for the pipe to move on the pipe support. The problem is that these do trap water, they do hold, and they make it very, very hard to inspect. You can't see that whole area that's covered by the FRP pad. And this statement here at the bottom is directly off of the website of the company that manufactures those. They say, corrosion-resistant wear pads are the best way to protect your pipes from damaging causes of corrosion and rust caused by metal-to-metal contact. Specifically formulated with a smooth exterior, our ultra-smooth composite wear pads effectively isolate uninsulated pipes from their supports to prevent corrosion. This is directly from their website. They're claiming that their product prevents corrosion. These pictures here were taken from a cell phone at a facility that had a leak and explosion at a gas plant in northeast United States. And you can see that upper left is a picture of the actual fire, and the lower right is the next day after the fire has been extinguished in the area of the plant that was damaged from the explosion. These pictures were sent to us by the investigator for that company. And you can see here that the upper left-hand picture, this is the loose sleeve, the same FRP pad that company claimed stopped corrosion. The loose sleeve was found under the failed area, resting on top of the pipe support the morning after the fire. This sleeve was 9.5 inches long and provided an extended area of contact corrosion. This large corrosion area explains the large initial blowout failure. Those phrases were taken directly from the investigator's report of the incident. So as you can see, that bad design has cost that company lots and lots of money and could have cost lives. In this particular instance, no one was injured, which is a great thing. So the solution is identify and eliminate the problems, which are tight crevices, the ability to trap and hold water. Eliminating dissimilar metal contact is a secondary benefit, and ultimately you want to open things up for inspection and maintenance. If you keep it dry, you eliminate corrosion. To enable that to happen, Deepwater Corrosion has manufactured a product called iRod. We've been manufacturing it for over 20 years. It's a thermoplastic material, excellent UV stability, has very low creep, or with the weight of the pipe it doesn't compress down. We call that creep. It has a very high compressive strength. 1-inch material will support 8,000-pound point load per rod. It's manufactured in 10-foot lengths. It's a cold installation, no need for hot permits. And standard sizes are 3/4 inch, 1 inch, and 1.5 inch diameter rod. The operating temperatures, the normal operating temperature is 90 degrees Celsius, 194 degrees Fahrenheit, standard material. The highest that it can operate at is 104 degrees Celsius, 220 degrees Fahrenheit. We also have a high temperature version, HT we call it, which can operate up to 200 degrees Celsius or 390 degrees Fahrenheit. We also have a peak material, which is pictured there in the center. That can operate up to 260 degrees Celsius or 500 degrees Fahrenheit. However, at those temperatures, water evaporates just from the heat. Often those are used just for wear protection against the pipe, for movement of the pipe against the pipe support. Another advantage to iRod material is that it's great for wear resistance. This here is a test run by an independent test lab. Found that iRod had superior performance as a wear pad substitute instead of those FRP wear pads, and the corrosion risk was eliminated. Ironically, the company that manufactured those FRP wear pads that we pulled the information from their website in a few slides ago hired this company to do this inspection or to do this test and purchase some of our iRod material. And what they did is they set up a test where the iRod had a piece of pipe on top of it, and they had the pipe move back and forth, a half-inch total movement in each direction on top of the iRod. And they did this test for 31 days. During the test, they had 5,760 passes per day, as you can see there. So each day, the pipe would pass over the iRod 5,760 times per day. And here's the results from that test. The first set of pictures is at 7 days, where they, at 5,760 passes per day for 7 days, you have 40,320 passes over that, which on a regular cycle of a operation in a facility, if you had 4 cycles per day, that would be the equivalent of 27 years. And after 27 years, there's slight wear in the plastic, and they've worked through the top layer of the coating after what would be the equivalent of 27 years. After 14 days, or 84,600 passes, again the equivalent of 58 years, they've now worn through the 2 coatings and gotten down to the primer, and there's very minimal wear on the plastic. On the 31st day, at the end of their test, after 182,520 passes, or the equivalent of 125 years at 4 cycles per day, they've finally worn through the coating and exposed the pipe, and there is minimal wear on the plastic. 125 years it would take. I think the coating would have failed by then under normal circumstances. iRod pipe support material can be used as a pipe rack beam dressing, as shown here in the picture. You can see 2 pieces of the iRod sitting on top of the pipe support with a various size pipes resting on top of it. Here's another picture of the pipe rack beam dressing. Also, we use the iRod shown here in the picture with a U-bolt, which is coated with the waterproof polyolefin that's heat shrink wrapped on there to stabilize the pipes at the pipe support. We use a cross-linked polyolefin. Galvanized U-bolts can be used, stainless steel U-bolts, or we also offer U-bolts coated with Cermagard in the event that you have a very highly corrosive environment. We also manufacture I-clips, which uses the same material as the iRod, and the iRod is machined to fit and clips into place on various supports. It has the same field-proven qualities of the iRod, clips into the existing clamps. You can see here in the picture you've got a metal pipe saddle with 4 of the I-clips clipped into place, allowing air to circulate in between the pipe and the pipe support, again keeping the coating dry, allowing the coating to do its job. And also you can inspect that and see that there is or is not problems at the pipe support. And you can see here how the clips clip into that particular saddle. These can be used for retrofit or new projects. They can also be used not just for saddles, for gripping applications. Provides a thermal and electrical isolation from the pipe as well as stopping corrosion. Can be used on grippers as shown here in this photo. Another way that we use the iRod material is in tubing control application to separate the crevice created when the tubing is too close to other tubing where water can be held in between those 2 at the crevice. You can see here the iRod material called T-SUP in this particular manufacturing scenario. We have a piece of the eye rod below and a piece of the eye rod on top of the tubing and fingers made out of the same stainless steel as the tubing. Separate the tubing, allowing air to circulate all the way around the tubing and keep it dry and avoid corrosion pitting. When it comes time to purchase eye rod, be sure that you don't purchase below-grade copycat materials. You can see here some various pictures of other companies' materials where they've tried to copy ours, and you can see that they creep, they smash down, and create a crevice, which is what you're trying to avoid, allowing water to be held there, and causes corrosion the same as if you had no pipe support. Look for the original eye rod name. You can see that on every eye rod we print the name of our company along with our website and a code. Each eye rod is coded so we know what the batch number is. Conclusions. This is a simple cold work installation for new or retrofit. It's inexpensive, has a 15-year plus design, protects the pipe coating system, allowing the coating to deliver the full life expectation. It's a simple application, and guidelines are available, downloadable from our website, available in 3 versions, up to 500 degrees Fahrenheit operating temperature. It's an excellent wear protection, has high compressive strength, a wide range of applications. Several thousand offshore structures have been fitted with this particular product since 1989, specified by most major oil companies. There are no reported crevice corrosion failures or repairs when the system is fitted. That's right, no reported failures ever. That is the end of my presentation. Any questions or comments, feel free to email me. You can also visit our website, www.stoprust.com, where there's a myriad of information downloadable from specs to information about application and installation. With that, are there any questions?
All right, Steve, thank you so much. I know you do have a couple of questions, but before we do that, I just want to tell everyone who's watching, if you do have a question about corrosion at pipe support, for Steve, please click on the red box with the right arrow at the top right side of your screen and type in your question. While questions are coming in, we'd like to let you know that today's webinar will be available online. And to access any presentation, just sign in to your NACE online homepage, and you should be able to view the slides there. And also, for all of you who are attending today, we will be sending out a survey. After that survey, if you complete the survey and respond to that email, you are eligible to receive a 1-hour professional development credit for attending. And Steve, it looks like we do have a few questions for you.
I see those.
All right.
So the first question, what material is iRod made of? iRod is a proprietary mix of plastics. It's a high compression thermoplastic, and like I said, you can download all that information from our website, www.stoprust.com. The next question, what is the maximum operating temperature of iRod? That question gets asked a lot, and I've breezed over it here in the presentation, but the standard iRod maximum operating temperature would be 220 degrees Fahrenheit. We also have a high temperature version which goes up to 390 degrees Fahrenheit, and peak goes up to 500 degrees Fahrenheit. Next question. We are always looking for better solutions, but I am surprised FRP is bad as stated. We have many of these FRP saddles, and as long as the edges of the saddles are properly sealed, no issues occur. So I think you are overstating the problem. However, iRod does seem like a better solution. Since this should be a technical presentation versus a sales presentation, can you comment on the clock spring pipe support system? I'm not familiar with clock spring pipe support systems. I've not heard of that, but I am familiar with the FRP, and in this particular question they say as long as the edges of the saddle are properly sealed. I agree with that if the edges of the saddle are properly sealed, then water would not or could not get in between the FRP pad and the saddle or the pipe. However, one thing to keep in mind is that the steel of the pipe expands and contracts at one ratio. The caulk used to seal around the FRP pad expands and contracts at a different rate, and the FRP pad itself expands and contracts at a different rate. So you have three different materials which would be expanding and contracting due to thermal changes, all changing at different rates, which causes the caulk to separate very easily from the pipe as well as the FRP pad. And if it's not maintained on a regular basis, it's very easy for that separation to have a small amount of water get in through a pinhole in the coating or in the caulking, allowing water to get in. And once it gets in, it can't get out, and you cannot inspect in between the two. So that could potentially be a major problem. Okay, let's see. Next question. Does there exist any study about the concentration of stress in the contact point with the eye rod? Yes, there is, and those reports as well as the studies, again, are downloadable from our website, www.stoprust.com. And like I said, the point load for a 1-inch eye rod is 8,000 pounds per rod, and the 1.5-inch rod has a 10,000 pound point load. Again, downloadable. How does eye rod make the pipe more inspectable? Well, especially in saddle type of applications where the pipe is sitting on top of a U-shaped type of saddle, and the depth of the saddle being whatever it is, if it's a couple of inches, that entire area that is contacting the pipe cannot be seen visually. You cannot look in between two metals that are actually touching each other. But if you put the pipe on top of a support like eye rod and lift it up off of the support, the metal support, you can see inside of there. You can also, it allows for air to circulate through there. There was a picture of the eye clip, which was clipped into the saddle, and you could see very easily that you can look right through there. If the pipe was sitting on top of the support, you just could not do that. I hope that I've answered that question well enough. Let's see, I agree the eye rod is successful, but what about the U-bolt that is only heat shrink protected? If it is damaged, then what is the guarantee of no galvanic corrosion? I suppose that's a legitimate question. We've not had that problem in the past. If you'd like, I can send you have my email address, syoung@stoprust.com. Send me your address. I will mail you some samples of the material. You can see that the polyolefin shrinked material is very thick, and it's very durable. It's also non-porous material, so it does not absorb water. It keeps water away from the pipe. And
we're not able to hear him at the moment. But what I can do, Mr. Rahim, is I can email him your question, and hopefully he can get back to you. If it's all right, I'll be happy to provide him with your email address, if you will, in the questions portion. Just write back to me, yes, if that would be okay. Okay. And let's see. And everyone, Steve, are you there right now?
No, I've lost her.
I apologize, everyone. If you all still have questions, please feel free to type them in. I will hold on for just a bit longer and just, say yes if you would like for me to provide him with your email address so he can answer those, and I will get back to you, or I'll make sure that I get those questions to him via email. And again, I'm so sorry that we've had a few technical difficulties today. More times than not, this does not happen, so I apologize for that and any inconvenience it may have caused. But again, I will just hold briefly in case anyone has any other questions.
Can you hear me now?
Oh, yes, we can.
I see another question came up. If you can hear me, I'll answer it.
Okay, I can hear you. We're good.
What effect will there be on the pipe, the concentration? Whoops, the organizer was dismissed.
Okay.
Okay, my email address is syoung@stoprust.
Um,
And I'm off of I've been dismissed from the presentation, so.
Okay, I'm not sure how that happened. Okay, well, like I said, I apologize that we've had some difficulties today. Like I said, this is not a normal anything that happened. So I apologize, Steve, and I apologize, audience, that we've had some difficulty today. Again, if you do have some questions, Steve is actually not going to be able to see them. I can. I still have my screen available. So please just go ahead and email or send over your questions. I will email him with your questions and your email addresses so he can get back to you. And I'll give it just a few more minutes. And Steve, if you want to
if you'd like, you can read those questions that you see. I just can't see them. You feel free if you want to do that. You can read the questions and I'll answer them.
All right. Well, I can do that.
Okay.
All right. The first one is a couple of them are pretty lengthy, so hopefully I can read them slow enough. The first question was, I agree the I-rod is successful, but what about the U-bolt that is only heat shrink protected? If it is damaged, then what is the guarantee of no galvanic corrosion?
That one I answered. I may have gotten lost.
I think you were cut off at that point. Yes, I apologize.
Okay. So the polyolefin material is really thick. It's heat shrinked on, and if any of you would like, give me your address. I'll mail you samples so that you can take a look at it. But we've never had that as an issue. We've never had anyone say that they've had that challenge, or we would find a better solution. The material is very thick, and it's also non-porous, keeping water away from the pipe, and so that's just never been a challenge.
Okay. The next one is, what effect what effects will have on the pipeline the concentration of the stress on a smaller point using I-rod than the traditional supporting design? Have you assessed the possibility of development of concentrated stress in the pipe?
We have, and every situation is different, and that is a valid question. As the pipe load gets to be too high, the pipe may bend before the I-rod changes because it's such a small point of contact. So in order to avoid that, as you saw in the pipe rack where there was multiple I-rods next to each other, it distributes the load more across more contact points. So if you have such a heavy pipe that the pipe itself may be damaged, then what we do is we install more than one I-rod at each pipe support, allowing that weight to be distributed among the different points of contact.
Okay, and the next question is, how long would it take to replace the pipe supports?
How long would it take? It depends on the company, I suppose. It seems to take longer for a company to make a decision to spend the money on that type of a project than it does to actually do the work. It doesn't take very long to actually do the work. You just lift the pipe up, install the I-rod. It's very simple to do. It would take minutes, potentially, although in real application, the permits and everything else that are required in a plant take longer than the actual work itself. But it's a very simple, easy, inexpensive, short time frame.
Okay. And then our next question is, do you think that in the Middle East, due to the high humidity and dew factor in the summer days, the IROD can be successful?
I do think so. The IROD has been used over there for a long time. We have agents all over the world. We have an office in the U.S. in Houston, Texas. We also have the same size office in the U.K. The Middle East would be handled out of our U.K. office, and it's been used successfully over there. I don't know the date of the first application, but it has been successful and is still successful.
All right. And Steve, thank you so much. Those are all of our questions for today. I see where a couple of you have asked if you would be able to have a copy of the presentation. We will be putting this on our NACE webpage, so if you are a NACE member, absolutely, you're welcome to log in on www.nace.org, and with your member number, you can view our archived webinars and see this presentation again. And thank you so much, Steve, and again, everyone, I do apologize so much for the technical difficulties that we've had today. And let's see, before I go, we've had a couple more people type in some questions. So,
fire away.
All right. Is it recommended to recoat the pipe before the IROD is installed?
That would be recommended if you have a section of the pipe where the coating has started to fail or has failed. If you're starting to see discoloration, it may make sense to sand or remove the coating at that area and then recoat that section of the pipe. That's usually how it's done as part of a maintenance type of project. They lift up the pipe, remove whatever bad coating or coating failure there is, get down to a nice clean pipe, and then recoat it, put the pipe support, IROD pipe support in place, and set the pipe back down. So yes.
All right, and I guess we'll wait just a few more minutes just in case there's any others. Let's see, and we do have a few more. Are there any coatings that are not compatible with the IROD material?
Not that I'm aware of. All of the coatings that it's been used with, we've had no conflict with our material or theirs. I'm not aware of any.
All right. And again, we'll wait just in case.
Thank you very much for all of your help, Allison. I really appreciate this.
Oh, you're welcome.
Putting up with all of the electronic issues we're having. So
No
it must
worries.
be weather. Could be weather.
It has to be. It's pretty nasty out there today.
Yeah.
All right. Well, it doesn't look like we have any further questions, Steve. And again, thank you so much, and I apologize for the technical issues we've had today. And everyone, thank you so much for your time and your patience and just your interest. And we really appreciate you sticking it out through our technical difficulties today. And again, you will receive a survey from today's webinar, as well as the opportunity to apply for your professional development credit should you need one. And of course, any other questions that you have, please feel welcome to contact Steve. I know that he'll be happy to talk to you all, and I know that we can also include your email address, Steve, if you'd like, when we send out that survey. So if anyone has any further questions or wasn't able to type in for any reason due to our technical difficulties today, they can at least get a hold of you.
Sure. Yeah, that would be great. I'd be happy to help them.
All right. Well, thank you again, and that will conclude our presentation for today.
Thank you, Allison.
You're welcome.